What's that?
Yeah, mine's not ready for 20 pounds back yet.
What did we change it to?
2 pounds, 20, or 2 feet, 20 pounds.
We changed it a little to 5 pounds or 10 pounds, I think. Because I was weighing 20 pounds the other day and realized that's a lot of mass to put on the bridge.
I think mine might be able to carry 5 pounds as it is. So I was looking at my bridge design and I'm like 20 pounds and I'm going to tear everything apart somewhere.
Yeah, I decided to change it and send that out.
So that thing there, 5 pounds?
A little more than 5 pounds. Like 5.5 pounds. 5.5. Let's see. Still like 4.4. Half is, let me see. This is 2.2 pounds. This is 2.2 pounds. This is 1.4. This is 1.1, so it's 5.5. It's a bag of flour, bag of sugar. About like that. Okay, so we didn't do any recording last Friday because I was the only one here. So I figured I didn't have anything to record. I wasn't talking to anybody. However, we are finishing up a bridge project. We have one bridge to test today. We're going to receive a video for a bridge test, hopefully later today or tomorrow, from our distance student, Vince Wade. Vince Wade. Can't remember. But anyway, sorry for not getting the name right, but I got the names right, I'm just not sure if I have them in the right order. And then also we have 2 students here in North Platte that we will test later as well. So essentially what we're going to do for the one bridge we have ready to test, this will be kind of our example. And let's see if I can, I'm pretty sure that we can do that right here and it would be visible because I think pretty much everything is visible. So we need a 2-foot span. We have to bring a,
I might have one in my car here.
I've got one in the room next door, I just gotta be good. So I'm gonna go get a meter stick really quick and we'll measure the 2 feet and we'll test it and we'll show it how it's done.
So yours is done?
Mine? No, I actually just got into the class. Last time when I showed up, that night, I get the phone call saying like, oh, you're not really a student yet. I was like, that's pretty hard. So I finally got it all figured out because I wasn't going to come to class if I'm not in class, you know. So I just got my little kit.
How many pounds? Maybe 5.
So we've got to measure 2 things, and that is, those are distance between our platforms, which in this case is a little bit big. Take it 24 inches, so there's 24 inches. And then we're also going to measure deflection of the bridge. So why don't you go ahead and bring a bridge up here and let's see how it goes.
Not exactly.
You just set it up the way you want to set it up. It's right between these 2 edges here on the inside. So it's not quite 24 inches. Well, the bridge is 24 inches, it just doesn't span 24 inches. So let's shorten it up a little bit. Now, where would that come into play in your evaluation of your bridge? So your bridge is 24 inches. When you evaluate your bridge, where are you going to put, it wasn't quite 24 inches? Because you have to put that in there somewhere. Probably in the part where you're talking about the functionality of it, where we had a function where it was supposed to span a 24-inch thing, and your design was 24 inches, right? The 24-inch bridge, of course, doesn't span a 24-inch gap.
Okay.
It has to be slightly longer.
And it's not quite.
And that's an important thing about engineering, is because sometimes the specifications of the bridge that you're given do not tell you the whole story, right?
Yeah.
You have to remember that there's another story involved. In this case, that story is the story of what a bridge is supposed to do. So we learn these lessons this way by making mistakes in the design process. And then we go on and try to not make them in the real world, right? So, this is how I'm going to load this bridge. I'm going to try to not necessarily load it at a single point, because bridges are not usually designed to have all their load at a single point. And we'll just start putting things on here. We got to measure the deflection, so I'll have you hold this up. Right there, and measure how much the bridge moves. You probably have to get down low to see that. So what's it at to start?
29. 29 inches.
29 inches. So that's there. Try to not let this slip off here. Maybe we should put some rubber on there or something, or some tape. Tape. I'll start with this here. Slipped off. Okay. More mass on there. Looks like your bridge is plenty strong.
It's even 2 feet wide.
What's it going?
Not bending.
Not bending, still at 29?
Nope. Well, one thing about 29, I wasn't quite on it. But
So should we try to weigh it down more? See what it can hold?
yeah, go for it.
All right, I'll be right back.
A strong freaking bridge.
Yeah.
And all it is 2 I-beams and a lot of reeds. What is that? 1, 2, 5, 6, 12. 14 of those sticks. And I think I was going to put more effort into it. Sure. Yes, you can feel like the KISS. You know what KISS stands for, right? Like keep it simple, stupid. I guess that was pretty good.
Yeah, that's right.
Is that the Baltimore truss bridge you were doing?
What?
The Baltimore truss bridge?
Okay, so these ones are about 11 pounds each.
Oh crap, you're gonna break these.
So we're going to double the weight on it almost immediately. That caused some deflection. Still holding. So I'll put another one on. Broke the string.
The bridge is still intact.
So here you can actually see the strength of I-beams essentially. You've called them C-beams. They're essentially the same thing. It's just an offset. They don't really have any difference in strength, except one is designed for a particular application and another one for the other application. But we're talking about an extreme amount of strength that has. And so you don't really even have to get into any kind of trusses at that point. And so now I know that 20 pounds is easily doable with I-beams. But still, it is deflecting it, and I think that with just a little bit more weight, it will break it.
You're trying to break it. You might need to put the benches closer together so it'll have more force on the brick itself and not on these little weak spots where it's connecting.
There's no, those are built the same as the middle.
Well, I mean, where this one can just slide off really light.
No, that's not going to break the bridge.
No, it wouldn't break the bridge, but it would drop it.
But so I'm thinking 20 pounds is probably the weights that we need to test with if we're going to teach our students to use I-beams. So you guys get to be, you're a good guinea pig. Now I know 20 pounds. But I think, well, we'll still test everybody's bridge with 5 pounds.
Yeah.
But in the future, since this is my first time doing this project in this class, and it's the first time doing it with different numbers. In the future, what we're going to do is 2 feet and maybe 50 pounds. 50 pounds? And make them really work hard. Well, because if you use an I-beams and you can hold 20 easy, then a more complex design with some, see, he's got some trusses worked into his.
I didn't do
You did too? You just didn't put them on?
Oh, I didn't have time to put them on. It finally started to rush.
Well, and again, that's actually part of your evaluation because your design and your bridge are different.
Yeah.
Right? And so maybe what I'm going to ask you to do is to finish your bridge, and we'll test it again.
Okay.
On Wednesday. We'll test Charlie's on Wednesday, and we'll have hopefully we'll have our other 2 bridges on Wednesday as well from the other 2 students. But I think that this could really be a project that really stretches the abilities. Now, if you were going to grade yourself on some of the other things, on some of the other points, for example, they talk about aesthetics. How would you grade it?
It doesn't look pretty at all.
It doesn't look great. However, I think it will look better if you get your trusses into it. Mm-hmm. But one of the things that we're talking about here is the care that we're using to make it. I think that these 2 things are about the same length, but they're glued together with the interlocking things kind of wonky, so that one of them looks longer than the other. Really, they're just shifted from each other. Mm-hmm. And then these things are not equally spaced, right, in the middle. They're different spacing. And there are tricks that you can use to fix that on a thing like this. Use a spacer, for example. Mm-hmm. So you put these things up against a wall so that they're flush. Glue that first one in, and then put a block in that is your spacer. Glue the next one. Take that block out, put it, or maybe you have several blocks, and glue them in with blocks, and then take the blocks out when you're done. Of course, the problem is that the glue will stick to the block if it's wood. Mm-hmm. So you got to be careful not to use too much glue, or to maybe use some wax paper or something like that. But use some kind of thing that will not stick to your glue, and then you can go ahead and put it together in a way that looks fantastic. And last year I had a student that just went so much the extra mile. She was an incredible student, and her bridge looked beautiful, and it held quite a bit of weight. She used less material than this, and I think it held 10, 15 pounds without any trouble, without any deflection. Mm-hmm. But again, it made use of things like I-beams and the truss. So this one right here was deflecting quite a bit. I would guess that if I put all this weight here on it, I would probably break it, or I could get close to breaking it. That's just a guess. But I'm pretty sure. So this thing probably has, I would guess, a capacity of maybe 30 pounds, maybe a little bit less, a little bit more. So I think for a challenge for you, that you go back and finish your design, finish building it. Okay. The design that you had, and then we'll test on Wednesday again. We'll test everybody's on Wednesday. But I'll test it to see how much it can hold. It's a good bridge. Thanks. Okay. All right. So you've kind of seen the testing procedure here. You want to have two platforms. Also, you want to probably modify this so that it can do the 24 inches.
That's why I said if you want to break it, you can. Because I'll probably
just keep using that. Just use that and build some pilings on the end of it. And that's not that hard to do to extend a bridge.
That's pretty easy. And it was part of the program, so I wanted to do it too. So this right here would be the leak point,
Yeah.
if you were to go. This is what I was expecting you to do.
So, okay, so anyway, so now you kind of know what to expect. You can go home and finish your designs, finish building, start testing a little bit to see how it works out. But we can also see here that that I-beam thing works really well. It's not that much material that he's got into that. How many pieces of wood? Maybe 8, 10?
Maybe 12 or 13.
12 or 13? Not too many. 12 or 13 pieces, and then your package of wood, I think I've given you 200. So it hasn't used up that many of his material, that much of his material. Just a little bit of glue and a little bit of wood, and he's got a bridge that already meets the specifications. If that was his completed design on paper, he could turn it in. Since it's not his completed design on paper, he needs to turn it in as his completed design on paper, right? And that's fine. And it should be quite a bit stronger, because what's going to happen as he builds the truss up above his bridge, he's going to have something to take away some of the stress from the bed of the bridge. That's what the truss is designed to do. As it compresses and stretches and contracts, it transfers those forces into other members of the bridge. So good design, good bridge so far. Let's see what else I wanted to talk about today. If you have questions about your bridge and you want some feedback, I will be available. You can send me an email with a video, or you can come into my office. You can do whatever. Call me up, and I will give you as much feedback. If you're running into a problem with your bridge, same thing. Come talk to me, or send me something, and I'll help you out. If you want to test your bridge before Wednesday again, you can come in, and we'll set you up to do that. What things can you use to test your bridge with? A bag of flour, a bag of sugar. Those are 5 pounds about. You can also get 10-pound bags of flour and sugar, and if your bridge is spanning a 24-inch gap, you should have plenty of room to either suspend that or just set that oil on the bridge. If you're using a truss bridge that has the structure above the bridge, I would recommend not putting the mass on the truss. The truss itself is not designed to hold the weight. It's the bed of the bridge that holds the weight. So try to suspend it from the bed of the bridge, or set the weights, sit the weights right on the bed of the bridge. And I guess that's all I've got then for today. You guys are finishing up designing. Everybody's got their build kits. Make sure that you have gone through the entire process and completed all of the alternative designs, completed the evaluating of the alternative designs, chosen your final design, and designed your final design on paper. Make sure that that's done before you really start building and completing the bridge. We'll push that off till Wednesday, and we'll start. Hopefully we can start off Chapter 2 by the end of this week and move on. You good? All right. We'll see you guys Wednesday. Get working on those things. Make some progress.